Okay, I'm just doing that for Brady's benefit. Okay, so we're going to do just a few problems together. They won't take as long as the others, but we need to do a few more, just some review. So we're going to do a couple more, or at least one more, maybe two more, with the division. Again, you do not have to do synthetic division, but I promise you it is faster if you can figure it out. So my advice to you would be, I'm going to do it for you again on the board. You can watch the video again if you need to review. But also, you could, there's some pretty good videos on synthetic division on YouTube. And I would say do that. I hope you don't, I kind of feel a little bit like I'm shirking my responsibilities here, but we just really haven't had time to take a whole day to practice synthetic division. When it comes down to it, it's just a matter of practice. It's not complex. It's not difficult. You just got to keep doing it over and over before you get in the habit of doing it right. But we're going to do it again. So, and let me remind you here, we're finding real zeros. We're not yet, though we have learned to work with complex numbers, we are not yet finding complex zeros on any regular basis. You might have the ability, you would have the ability to find a complex zero using the quadratic formula. You actually could do it. You may not know you can do it, but you can. You know how to do it. But after the exam, and after when we start back up, then we will actually talk about finding actual complex zeros. And there's something, it's called the fundamental theorem of algebra. You might say, well, fundamental theorem of algebra is fundamental, that I should have learned it in Algebra 1. Well, you didn't. Because the fundamental theorem of algebra relates more to complex numbers than it does to real numbers. I know that sounds dumb, right? Complex numbers, remember, are the numbers that are. So when you learn the set of numbers, you learned there's real numbers, right? And you learn that inside of real numbers, there's you've got actually I should do it this. You've got real numbers, and then you've got rational numbers and irrational numbers, right? And then inside of rational, you've got things like, whole numbers, and then integers, and then inside that you've got naturals, right? So it gets smaller and smaller. Here's the reality: you were taught that the real number system included all the numbers, right? Is that basically what's implied? That's what I tell my pre-algebra students and my algebra 2 students. The real numbers are all the numbers, but that's not true. There's a bigger box, and that's complex numbers, and real numbers is a subset of complex numbers. But you spent your entire life dealing with real numbers, and now we get to deal with complex. So I said all that to say we're not really doing that just yet, but we're going to be getting there eventually. So let's try this with that function. So our function is f of x equals x cubed plus 2x squared minus 5x minus 6. All right? So, what are we going to do? Well, first thing we can say that there are at most there are 3 zeros. Okay. Again, when we get to the fundamental theorem of algebra, you're going to find out fundamental theorem of algebra says there's exactly 3 zeros. But that, at this point, so the thing is that it says there's exactly 3 zeros, which means if you can only find one real zero, then there's got to be 2 complex zeros. That's where it gets messy. That's where it gets confusing. So that's the fundamental theorem of algebra. We're not there yet, but that's what we're going towards. So at this point, we're saying there's 3 zeros. Now, if we do Descartes, we can find out how many positive and negatives. I'm not going to do that today. You know how to do that. You know how to do Descartes and find how many positive and negatives. But we will do the rational number theorem. So we know it's going to be 6 over 1, or P over Q, right? So that's going to be 1, 2, 3, 6 over 1. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are your possible zeros. Okay. Does everyone understand why that's true? Does that make sense? Like, remember back, like when you're factoring a quadratic, what do? To do that, you normally take and you find all the factors of your constants, and you find the factors of your leading coefficients. And you've got to find, and then you're going to try to find those things that add or subtract together to give you the middle term, right? That's what you do with a quadratic when you factor quadratic. Does everybody do that? Okay. You ever use the magic X? I don't think Mrs. Barnes doesn't teach the magic X. She doesn't really like that very much. She doesn't hate it. It's just not her favorite. Magic X is something that I teach. It's just a trick. It's not special, but all it is factoring. So that's why these factors work, because you know that you've got to if it's going to be a zero, it's got to have no remainder. So that means that it's got to be a factor of these two things, the constant and the leading coefficient. It's got to be a factor of those two things. So we've got those. Now we could graph it, and if somebody doesn't mind, if you got a graphing calculator or you have Desmos up on your computer, graph it quickly and tell us which ones are the likeliest ones. And again, you probably can trace it those which are the exact ones, but we want to know the likely ones. Or pick one, I don't care. Anybody see one?
Okay, the likely is -3, -1, and +2.
So -3, -1, and +2. So those are probably not only likely, they're probably actual. They probably are. But we want to be able to do the math. Okay. So to test one of these, we're going to do it. We're going to test one of these. We'll test -3. And we're going to do it using synthetic division. So our coefficient is 1, 2, -5, and we have -6. Now, first step in this, bring the 1 down. We multiply. I'm just going to make this for you again, just so you can remember. Multiply. Okay. Multiply -3 times 1, you get -3, and then you add. So I'm going to do that. Add. 2 plus -3, -1. -3 times -1 is going to be a +3. -5 plus +3 is -2. -3 times -2 is a +6. -6 plus +6 is a 0. There's no remainder, so it is a 0. Therefore, we know that x minus -3, so we would say x plus 3, is a factor. Okay? Is a factor of this of this, and we know that negative 3 is a real zero and x plus 3 is a factor. Okay? Now then, the right thing to do then is to keep going and to test more. But you can simplify, you can make it easier on yourself by then, if the degree of this is 3, the degree of the next one is just 2. So it's x squared minus x minus 2. That's your new. So here's your factors. X plus 3 times that will yield this. So now, if one of these, if they're true, if they're actual real zeros, that doesn't say it that way. If they are real zeros, then they'll also be factors of this. They have to be. It can't be a factor of the whole thing and not be a factor of this if you've already taken out the other factor. So, we're going to take x squared minus x minus 2, and I'll do that one. We'll do it right here. So we go 1, negative 2. So we're going this way. And we'll test, let's test negative 1. So we bring our 1 down. Negative 1 times 1 is negative 1. Add those together, we get negative 2. Negative 1 times negative 2 is positive 2. Add together, we get 0. So hey, there it is again. Yes, sir.
Could you have just factored x2 minus x minus 2?
Yes, you could. And yeah, it'd probably be faster. But I wanted to keep doing the synthetic division just because it's so much fun. I actually do like synthetic division. But I wanted to give you guys a chance to see it again, but you're right, you could have factored it. Once you get down to a quadratic, you can factor if it's factorable. So, which again, going back, I know I'm previewing, which probably is not the right thing to do now, but just so you know that this is meaningful. So the fundamental theorem of algebra, when you go further, ultimately says that every quadratic that has the potential or can be factored down to factors plus an irreducible, either factors or factors plus an irreducible quadratic. This is a reducible quadratic, but it can be either factors plus or factors plus irreducible quadratic. So when we look at these, we often think, well, no, there's no way to factor that. And sometimes we could write one that we could say, we can't see any way to factor that. But the reality is they can be factored. It's just that they might have complex zeros or they might have irrational zeros. So, all right. So that gets us to there, that is just x minus 2. And we already know that x plus 1, that's x minus negative 1 is x plus 1. So there's your 3 factors. So your zeros are negative 3, negative 1, and 2, just like we found on the graph. So, but you see how we did that? We proved it using synthetic division. Now, what's weird about the next one? There's no third degree. So that's what I want you to see that as well. So let's look at the next one. Okay. Now, so we can do this in the same old way. I wonder, can anyone see a way to factor this?
You make it x squared instead of just x.
So if you did,
X squared minus. No,
It's not a pretty.
oh wait, plus, no, yeah, no, it's minus, yeah. Minus 1 x squared plus 2. Does that work? Does that,
I think so.
so we do first, we get x to the fourth. We get negative 1x squared, positive 2x squared, this is that, and negative 1 times 2 is negative 2, so that works, right? So if you can factor them, feel free, right? You don't have to do the synthetic division thing. But here, so here we factored, this one can factor further to be x minus 1 times x plus 1, right? So there we've got a 0 at 1 and a 0 at negative 1. There's 2 of our zeros. X squared plus 2 is not factorable. However, we can, if we want to set it equal to 0, we can solve it, right? We can solve it for 0. So if we do x squared plus 2 equals.
Bringing Carson, Clay, and Caitlin Gilbert to the front office for checkout, please. Carson, Clay, and Caitlin Gilbert to the front office.
Did I mean to do that one? I just wonder if I'm not sure I wrote that one down correctly. I'll look at the book. Yeah, I'm not even sure I wrote that. Oh, no, I did. Okay. Yeah. So again, we've been talking about complex numbers. So we know, do you know how to do this? We kind of learned this a little bit.
square root of the second.
What's that?
You get the square root of either side.
Well, yeah. And when you get square root, so you get square root of the other side, you can get x equals the square root of negative 2, right? And so that's going to be x equals the square root of 2 times I. So that is a complex 0. Now, if we had done Descartes' rule, we followed Descartes' rule, we would have found that this only has one positive and one negative real. And we could have said, we've only found all the reals, and we could have just stopped and said, well, anything else is complex. But here, this shows you that's what the complex is. So the complex zeros are it's actually, I guess, going to be plus or minus. This way it would be. Plus or minus square root of. So, but don't sweat that. All right. So that's, everybody, do you feel like you understand how to find real zeros? Okay. All right. I know that we really beat this horse to death, but I just want you to do well. I want to make sure you understand it, because it does get harder when we start finding complex zeros. So, all right, let's look at one other thing then. How I don't know. So this is not finding real zeros. These are just that x to the fourth minus 16 is supposed to have equal 0 after it. So, but don't worry about that. We'll be right. Let's just try solving these. We did arithmetic or algebra in the complex number system. These require the complex number system to solve. So 5x squared plus 2x plus 1 equals 0. Well, first of all, could we, can we factor that? I don't think so. Doesn't look factorable to me. Yeah, there's no way to factor it because you have everything's positive and so then. So you can't factor it. So then what do you have to do if you can't factor it? If it's a quadratic and you can't factor it, how do you solve it?
Quadratic equation.
Quadratic, yep, the quadratic formula, quadratic equation. So, okay. The b squared minus 4ac? What's that?
Negative b.
Negative b, thank you. I don't have it memorized. I've tried. But
My teacher made us home about it.
somebody else told me that. What's the song?
I don't want to say
You know it too?
The pop goes
it.
the
Not
middle
that
one.
gutsy, yeah.
Someone else? Is that the,
Think of the rhythm, pop goes illegal, and then do that.
okay. I still can't do it. All right.
I'm sure you could find it on the YouTube.
Probably. All right, so that's it. So -2 plus or minus square root of 2 squared minus 4, 5, minus 1, all over 2 times 5. So we get your 2 plus or minus 4 minus 20 all over 10 . Okay, so how do we simplify when we get there? This is where you use the complex. What do you think you do?
Take as much of the square root from how much you can. I don't know what you call that.
So you can go, so I really have messed myself up by writing out all the way over here, but anyway. So you can go square root of 16 times square root of -1, right? You can, and that is going to equal -2 plus or minus 4 I all over 10, and that can probably be reduced, right? So you can take a 2 out, I guess. So you can go so you get -1 plus or minus 2i over 5. So, yeah. Now, it seems like the textbook reduces that further, but I don't know. No, it doesn't. Sorry, it doesn't. It doesn't reduce, it just separates it. The popcorn?
Yeah.
I'm sorry.
I'm gonna go into work selling my current popcorn.
What's that?
I'm gonna go into work selling my current popcorn.
I'm really sorry. I'm really sorry. So at first I'm like, did she do this on purpose? But I really think what happened is,
Yeah, like it's like you want to avoid it's not actually harmful to a person. Get back to somebody. Right.
well, I think she hit the potato button. And, you know, the potato button senses when the potato, like, senses the moisture or something. Well, popcorn doesn't provide that sense, and so, I don't know, it cooked for a long time, and like, I had no idea, the door was closed, I couldn't hear it, I don't have great hearing either, I couldn't hear it, I couldn't smell it, nothing, and she comes back in.
There could have been a fire.
Yeah, I know, they could have started on fire,
So sad.
Oh, God.
and she said, like, she said, what do I do? And I'm like, well, throw it away. So don't throw it away here, throw it away in the hallway. She said, should I put it in a bag? I said, probably, you know. But so I didn't even look at it, but it could have been black. I mean, the inside of that,
It has it. It's like toxic fumes.
the inside of the microwave is all brown.
Oh,
She's-
my God.
That's cute.
All right. So anyway, so the solutions are, there's always two solutions, right? When you do it like this. -1 plus 2i over 5 and -1 minus 2i over 5. Those are your two possible solutions. Right, so you would write it like this. -1 plus 2i over 5 or -1 minus 2i over 5. And you can separate them if you want and just make two denominators instead of one denominator. I think that's neater, but the textbook separates them. So does that make sense? So if you get a quadratic that you cannot factor, and so you do the quadratic formula and you get up with a negative square root, in the past you've always said, oh, well, that's undefined, that doesn't work, we can't have it, right? Up until now, we used b squared minus 4ac, we called the discriminant. In other words, if b squared minus 4ac was negative, well, then you couldn't do anything with it. But now we're telling you, yeah, you can do something with it, and that's this. You change it, you pull out a -1, square root of -1, which is I, and then then you deal with the other side, whatever's left. Okay? So one more. Let me make sure that's supposed to be equal to 0, I think. Let me make sure. Yeah. Sorry, I didn't type all that in. Okay.
Yeah, are you allergic to Febreze too?
I don't think so. I didn't even know. That's the only time I've ever had a reaction to Lysol.
Was when you were here.
That was
Yeah.
so bad.
And again, I was broke out from head to toe.
Oh, my
That's
God.
why when I went to the hospital, I said, I don't know what's happened, because I am allergic to, I don't have a ton of allergies, but I am allergic to some detergents. So my wife, we can only use Tide, which is expensive, it sucks, because I can't use the cheap ones. So we can only use Tide and I can only use Downy. If somebody uses a different detergent and a different fabric softener, I break out. So I thought that she had bought cheap detergent. And she's like, no, I haven't. And so then we realized it was all of my body. Like, what are the chances that all of my clothes were washed in the same thing anyway? Because, they get washed in, dark lights off and stuff. Like, okay, well, that wasn't it. So we went to the hospital, and as soon as they saw me, they said, well, you had to ingest something because it's everywhere.
You ingested?
I ingested Lysol. That's how bad
Everywhere.
it was. It was like a cloud in
We
here.
all did. Like it was.
Yeah.
It was so bad. It was at least half the can gone. No kidding.
It was crazy.
Well,
It was like a
before,
cloud
and
in
then
here.
it made it 10 times worse. It already stank before, and then it made it 10 times worse.
Yeah, and it tasted, and you could taste it in
It
the
was
air.
so
We
bad.
were all talking when we weren't paying attention, and she's still spraying it everywhere.
Yeah.
So anyhow, that was, and so I went to the hospital, and so then they gave me,
Did you get
they injected me, what's that?
an EpiPen?
They injected me, I didn't need an EpiPen because I was still breathing okay, but they injected me with an antihistamine, and then and it went away. It did over time. It took all night, but yeah.
I want to see an EpiPen in action. Really, I remember us doing like so bad. You were a substitute teacher. We had never met you before. And all of a sudden,
And then all of a sudden you're in the hospital.
It was awful.
Only our class would be the one.
Yeah.
That's very true.
Anyway, it was
We
fun.
were all
Some girl that used to go here.
I wasn't angry. I was shocked. I'm like, what the heck?
No comment to that.
So, all right. So this one now. Here again, we can. You can ask the question: can we factor? Right. So this one, you can factor x squared minus 4 times x squared plus 4. Right. So then we're going to get x minus 2 times x plus 2 there. So those zeros are easy to find. Those are real zeros. And x squared plus 4. Again, now with factoring, this did not require the quadratic, but we're able to factor. We're now again with x squared plus 4 equals 0. We subtract 4 from both sides. And we take the square root of both sides. You get x equals plus or minus the square root of negative 4, which again, you can solve now. It used to be you had to stop there and say, well, this is unsolvable, but now you can't. So what do you have to do to solve that? We've just done it a couple times, I know, but what do you have to do? To deal with the square root of negative 4. You can't leave it like that. That's actually not a solution.
The square root of negative 1 and the square root of 4.
Exactly. So that equals, we'll just go up this way. Square root of 4 times the square root of negative 1. So we'll do plus or minus, which equals plus or minus 2i. And you're done. So here's what you're going to find out. So you know when you do the quadratic, right, you always end up with the two solutions, right, because of the plus or minus. Well, because there's a square root, right? Well, the only time you need the complex number is when there's a square root. So there will always be two complex solutions. If there's a complex zero, they always come in pairs. Now there could be 4 or 6 or 8, but there will always be 2. They always come in pairs. There always, if there's any, there'll be 2. Does that make sense? Okay. So do you all have any questions? I feel like we're getting done way earlier than I thought we would. Do you all have any questions?
Oh, during the test, probably.
That'll be okay.
Is there anything?
My mom's like,
Okay. All right. We'll cope with that for you. Yes.
What is it going to be the most heavy on, or is it going to be like all evenly on?
Okay, so I gave you all, like, we did that review thing, right?
Is it on that?
It's gonna be just like that, and it's just.
the review, like this paper.
Oh no, not that. I did not give you a different one too.
No.
I'm sorry, maybe I did.
And it's that paper that like I'll be like cool with that.
Yeah,
Let
me
me
too.
I think we can do that.
let me pull it up. I'll just.
Crunch on the line.
Yeah.
There's gonna be a couple of those. Okay, so yeah, I'm sorry. Okay, I lost my mind for a minute there. I know this is pre-calculus, but my mind went to I was seeing in my mind's eye, the Algebra 2 review that I gave.
You can give us that one instead.
Yeah.
Oh, that's boring.
See like the 3 hours review.
Okay, so,
We can get that one.
okay, so here's what we're gonna have. I have it almost completely done, so I'm gonna add 1 or 2 little things, but, we'll have one of these, a quadratic, that you're gonna end up with a complex number. You'll have one of these that you can factor, and then you'll have one of the real zero things. And then you will have, let me pull it. Well, I know I have it here somewhere. I'm just having trouble finding it. So, okay. So again, what we're doing is just the second part of the test that we gave you before. It includes these, like I said, these things, a quadratic, a factorable one, finding a real zero, probably two of those finding real zeros. And then the arithmetic with, that's not a fair term to use, but basically operations in the complex number system. So you're going to do, I would not FOIL it, but you can. It's okay. As a matter of fact, Caitlin, didn't you say you preferred to FOIL it? That's fine. If you want to FOIL them, but you can do that. Now, remember, I would at least look in your book, because if it's a conjugate, remember what a conjugate is? So conjugate means, so if you have, the conjugate of that is A minus,
It's the
I have no
freshman.
idea, but they're crazy.
So shocking.
Um,
Shocking as a fucking.
That's a real mess because this penny's broken. So if you have the conjugate, remember this is a lot, the solution of this is way simpler. And so I would at least look in your book to do this, because we'll probably have one of these on it too. It's not that difficult, but yes.
Just want to double check. I'm pretty sure you said it before. Are we allowed to use our book? to look at
Yes,
formulas?
book notes. Yeah, I am not. I don't remember. I took high level math classes in college. I wasn't great at it. Some of you already are close to excelling me, and some of you will definitely excel me mathematically. But I don't remember any of my professors saying, "Hey, you got to remember all this." Now, again, our tests were pretty stout, and so you didn't have time. You didn't have time to learn it in a test period, but you certainly had time to look things up. So I don't know. I don't think it's, I don't think it's fair to ask you guys to remember all these formulas and everything. It just doesn't help.
I appreciate that.
So anyway, but in your textbook will show you what this is. Let me find the page. Okay. So I thought so the textbook does tell you this, but so if you had a typical conjugate, like if you had x plus 2 times x minus 2, right? That becomes x squared minus 4, right? when you, in the complex number system, it's very similar, but it's not, it is, instead of being a squared minus b squared, it's a squared plus b squared. Now, why is it plus?
Because the I squared becomes a minus one.
Because I squared is -1 and it changes it. So a squared becomes a squared plus b squared. So that's the thing. So you should know that. And you can find it, I'll tell you the page that that's on. It's on page 268. So, all right. Well, finals are coming up next week. You guys are tired. Let's just chill. Do what you want. Don't act like them. If you come up with any questions, you can ask me. You should look. If you're a person who gets on RenWeb, you might want to look and make sure everything's okay. Like I said, most of you are in pretty good shape. Even so, and I know I don't say this just to flatter you, but you're my hardest working class easily. And I realize that doesn't mean that everybody works as hard. I mean, some of you probably don't work as hard as others, but you're my hardest working class, and so most of you are doing pretty well. There's still a few of you who probably want to turn in some corrections if you didn't. Now's a good time to work on those. If you need help, especially, I can help you, or you're welcome to get help from a friend. I don't care. If you need to do corrections, not everyone needed to do that, but a few of you needed to. So, anyway, all right. All right, let's end the video.
Let's see, Douglas, can you go on a walk?
It's fine with me. Just don't get me in trouble, right?
We're not that
We'll
loud.
say
We
we're
won't tell them, we'll be quiet.
Because
We'll say we're